Good evening. Welcome to this session on selecting a methodology and research design. And basically, it is an introduction to quantitative research. You will note that last week we were meant to have part 1, and this week was going to be part 2, but I will make every effort to combine both the detail for parts 1 and part 2 into this session. My name is Professor Tennyson Mokuchini. I am the Acting Executive Dean for the College of Graduate Studies, and I also happen to be the project leader for this accelerating Masters and Doctoral Support Program that we have here at UNISA. Also, tonight I am your presenter. So, as I say, we have 2 sessions to cover. Basically, what this session does is it's going to be an overview of quantitative research methodologies. And as I walk you through them, I will occasionally direct you on how you can ascertain whether this is an appropriate methodology for you, and if indeed some of the design options within it could work for you. Just for those who are new to this format of presentation, please note that you have a question and answer tab that allows you to post questions for my attention. I will save them, of course, to the end, and at that point I will work through all of them. And also another additional issue, the session will be recorded for you to access, and also we will be circulating a copy of the presentation that you see. So please don't worry too much about trying to copy it verbatim. You will have access to both the recording and the actual presentation for yourself. As I say, we are kind of reaching for somewhat of a lofty goal. I'm combining 2 sessions into one and trying to cover what is ordinarily quite a difficult topic, but I'll do it all in one setting. Just so you understand how I work with my slides, I tend to have many more slides than the ones that I will refer to. So I think this session probably has in excess of 70 slides, but we will probably speak to about 30 of those at the most. And the reason that I have additional slides is so that if you refer to the slide show on its own, you're able to connect the dots as if I were in the room. So that's intended to assist you with how you will work through the slides in my absence. And of course, another arrangement that we have is that I will be, in a moment, I will be sharing the presentation with you. And when I do that, I take the camera off and allow you to focus exclusively on the presentation that you have in front of you. Of course, please post your questions as we proceed through the session, so that at the very end we've got all the necessary questions populated. I will respond to them then. It is our hope that we will be able to finish somewhere between 7:30 and 8 p.m. Depending on the number of questions that are posed to me, and of course the speed with which I present the slides that I have for you. Once again, welcome to the Quantitative Research Methodology and Research Design sessions, and this is session 1 and 2 combined together. Welcome. Right, as we begin to look at this, please note once again that we are looking at quantitative research design and methods, and this is targeted both for masters and doctoral students. And the reason we do that is the foundational information that relates to both to research designs and to methodologies is pretty much the same. So the knowledge that you need to have is very similar. The extent to which you utilize it, the complexity with which you utilize it, all of those things differ depending on the level of study that you're at. So, right now we proceed on to a brief outline of some of the outcomes of this session. Firstly, I intend to give you insight into how we describe the most common quantitative data collection approaches. I want to give you insights into knowing how you can analyze the strengths and weaknesses of each of these data collection options that I share with you. Of course, we need to think about the fact that in quantitative research, our interest is using numeric subject, numeric units of study, and we have to have a process by which we select them. So in aid of that, I will support you to develop an in-depth understanding of the concepts of sampling, population inclusion and exclusion criteria, and we'll of course work through how you develop sampling strategies within these quantitative designs that I will speak you through. And then of course I will give you some sense of the automated sample size development options that are available to you. Once again, and I say this more as a disclaimer, but it is an important point of departure for any session. We on this program give you basic concepts that allow you to build your work around. We of course intend to have workshops that will allow you to focus much more explicitly on some of the challenging and more difficult concepts that we speak to. So take this as the cursory or introductory insight into quantitative research designs. As with all things research, my view is always that we need to get you to have the basic expected principles located appropriately so you can understand what we're going to discuss. And what I've done is the first 5 or 6 slides touch on some basic principles that you need to know. These principles are not exclusive to quantitative research. They are relevant to all research, but I need to be sure that you have them as a background, because if you don't, some of the concepts and issues that I discuss might seem somewhat difficult for you to deal with because you do not have the necessary background. And at the very, very, very start of all this is making sure that we have an understanding of some of the definitional direction that's given to us when we talk about research, when we talk about the research process. So firstly, many have tried to define research, and all the good definitions tend to gravitate towards a very defined set of principles. Firstly, I want to draw your attention to this definition by Sackett et al. This definition I like because it really outlines the key expectations that everything to do with research has from you as the person who's doing the research. So you should remember that by nature, research is systematic, it's rigorous, and involves a logical investigation that aims to answer questions about a phenomena of interest or a problem. I'm going to spend a minute or two just breaking this down because I need you to get this, because it is where all your behaviors, your choices, how you approach and deal with research issues, they all come from this very basic set of words that I've just shared with you. Firstly, when we say that research is systematic, what I am saying to you is that every choice you will make, and I mean every single choice that you will make in relation to your research, must have its genesis or should be born out of a system of knowledge, a system of thinking. So whatever it is that you decide on, whatever it is that you choose as your problem, whatever it is that you decide to make your objective, whatever it is that you decide to have as your data collection approach, your method of analysis, your method of sharing results, all of them must in some way be able to be traced back to some system. So there is no guesswork. Anytime you see yourself doing things that you believe are a thumbsuck, or you've decided that I'm just going to do this because this is what I like doing, you must know that you're doing something wrong. Because research is about systematic everything. Every single decision you make is systematic. So if I ask you, why is it that you've chosen this topic? Why is it that you've chosen to collect data from human beings and not from other people? All of that needs to have its origin from some type of system of knowledge that informed you. Then this issue, the next bit we talk about is rigorous. And rigorous literally means being able to look at everything from every possible angle, from every foreseeable angle that exists. So when we say research is rigorous, we're saying that it is a 360-degree enterprise, that anytime you do research, you don't only interest yourself in those things that are of direct relevance to you, you interest yourself in the views and opinions of all the other different representative thinking stakeholders that are there. And so when we say rigorous, we're saying, look, if you choose to go left, you need to have considered all the other directions that you could have gone, and you need to have considered why those other directions are less appropriate than the direction you've chosen. And that is a fundamental requirement of research activity. So any choice that you make needs to be made because you have excluded every other possible choice. So, or you've looked at all the other possible choices and you've assured yourself that this choice you make represents the best choice for that moment, for that occasion, for that event. So clearly, the issue about rigor is littered everywhere in research. If you decide that you want to do quantitative methodologies, the first question people would ask is, why not qualitative? Why not mixed methods? What is it that drove you to do this? In this world of rigor, there's a slight limitation that exists. And all of this that I'm sharing with you becomes your Bible. Hey, when everything you do in research, you remember the systematic nature. If you can't explain your choice on the basis of a system of knowledge that informed you, then that choice is not a good choice. And if you cannot show that you've been rigorous and you've looked at all the options that are available to you before you arrived at whatever choice you made, then that is not research. If you cannot walk the reader through a logical set of steps that you went through to get to where you got to, then there is a problem. So that logical investigation you are assisted with by the very fact that there's something called a research process, which tells you that when you are dealing with research, you must conceptualize the problem, you must plan for the problem, you must investigate the problem, you must disseminate and share the outcomes of the problem. So that process that we call the research process, the methods, the steps that you follow when you're finding out about a topic, examining it, reporting on it, and so forth, it is all part of this logical investigation requirement that research has. And then the other critical thing is that research must always aim to answer questions about something of interest or a problem. So you cannot, everything about research is about answering questions. It is about answering whether A is related to B, answering what factors result in A changing. It's always a question. So if you cannot phrase what you are studying in the form of a question, then you have a problem, because ultimately it means you have not created it and conceptualized it like a research issue. So, and of course, in there it says it must be a phenomenon of interest or a problem. So unless you can prove that thing you are studying or the topic you're looking at is of substantive interest or represents an unsolved or poorly understood problem, then it is not research. So what I have told you now are what the key identifiers of research are. If it is not systematic, if it does not show rigor, if there's no logical investigative process within it, if you're not aiming to answer a question about a phenomenon of interest or a problem, you cannot say that you are engaging in pure research. And because all of you come to us with these things you want to study, it is your job to make sure that the thing you study looks systematic to me. It has all the hallmarks of rigor. It is presented logically. It aims to answer a question that you can demonstrate is of interest or represents an unresolved problem. If you can't create that as the setting of what you want to study, then you've got a faulty research problem. And I spent a lot of time on this, and I do that because essentially everywhere throughout the development of your work, these are the foundational things that you need to have. If you don't have them, we don't have research. Then, of course, the process by which you engage in this activity that I've defined for you is what we call the research process. And that is, simply put, a methodical step-by-step approach to finding and examining a variety of reliable scholarly resources on a particular problem area. So basically, the research process is the steps that you follow to engage in that systematic, rigorous, and logical investigation. So this is one concept I needed to get clear with you. The next concept that I need to get clear with you, this here is a repetition of what I've presented to you, but I present it there for you to kind of see and understand things. Similarly, one of the things that we assume you know by the time you get to master's level or to doctoral level is that you know the difference between quantitative designs and qualitative traditions. And what this slide does for you is it basically offers you those differentiators. I will not get into them, but I will pick out some obvious standout issues. So quantitative research, as you know, it seeks explanations and predictions so it can develop generalizations. So in quantitative research, I will want to study relationships between things that I know to see how they are related to each other, how one may cause the other, the strength of their relationship, so I can use that information to predict and give generalizations about how those variables and those issues behave in relation to each other. That is the purpose of quantitative research. Qualitative research, on the other hand, isn't interested in predicting things. It's not interested in developing generalizations. It's only interested in better understanding complex phenomena, things that are complex and need to have depth for them to be understood. But that depth can come from very limited number of things. So in qualitative research, you can do a study with 5, 8 people. As long as you get the depth right and you meet other qualitative principles, you are fine. Of course, the research process for both of these, in qualitative research, you generally don't know what matters when you enter into the study. You are dealing with unknown variables that will emerge as you do the work. And a lot of time, what is given to you is of a subjective nature. When people give you their insights as people experience something, but what you will discover emerges as you do the work. In quantitative research, however, the variables are known. A lot of the times the items are understood. The things that matter are understood. We want to see the relationships between them, the strength of the relationship, the direction of the relationship, and so forth. When we gather data in each of these, for one, we're interested in numeric data, representative large samples, and we use standardized instruments, where in qualitative research, it's more narrative data that we get, narrations, textual data, oral data. We use small samples, and then of course we're basing this on loosely structured observations and interviews. You will see the analysis approaches. Quantitative, we do statistical analysis types, whereas in qualitative research analysis, we look at the search for themes and subjective observations of a phenomena. And findings, of course, as you can tell, some are presented in a very numeric, statistically based way, while others are presented to you as words, narratives, literary style, and different types of quotables that are given to you. So that I'm giving to you to make sure that you have necessary background for us to engage meaningfully in what I'm about, Secondly, or thirdly, actually, we have in quantitative research, the very nature of quantitative research is that it concerns itself with numbers. It concerns itself with deciding what means more than the next thing. Qualitative research, every view, regardless of where it has come from, is viewed as being of equitable or comparable importance, because it is, after all, if participant A gives you their subjective view and another gives you a different subjective insight, there is no requirement in qualitative research to say the view from one is more important than the view from two. But in quantitative research, we are interested in this sense of evidence having different levels of quality, that if you use different types of evidence, you will get a different level of quality from the work that you are looking at. So in the interest of that, the quantitative researchers came up with what we call a hierarchy of evidence. And what I have presented to you is just an example of one such hierarchy. There are many hierarchies that are created, but this is one of the most fundamental types of hierarchies, and it is developed by a person called Sackett. And I think the reference we used for the definition of research is actually spearheaded by the same Sackett. And Sackett basically was a researcher in engineering, if I don't get it, if I'm not mistaken, in New York back in 1984. He was very distressed by the fact that, you know, in quantitative research, you come across a lot of studies that are saying different things about the same phenomena. So if we take, for example, in its very, very early days, when people were contesting whether cigarette smoke kills you or not, there were studies that would say, no, cigarette smoke doesn't. Some would say it did. There were studies that said it only did if you were a direct smoker. Some were saying if you secondary smoke. Some were saying if you are a passive smoker. All these other different, and all these studies were saying different things and all claiming to be the truth. In quantitative research, there's a need to understand which represents a much more defensible truth than the next. And what Sackett came up with was this hierarchy that gives us basically a sense of the importance and how more verified information is. And what he argued was that, look, not all research is made equal. That's the first tenet, and that certain types of research are more robust and represent higher qualities of evidence than others. And his view, he drew this diagram that you've got in front of you, and his argument was that, look, systematic reviews Systematic reviews. And systematic reviews are where when someone takes a whole bunch of quantitative studies and reviews them to see how well developed they were in terms of the methodologies they used, what deductions they came up with in answering a particular question, and then takes maybe this body of 100 studies and evaluates them so they can get a collective quantitative truth from them. That represents systematic reviews. So it's the opinion of many, many papers that have been reviewed. Then, of course, so his argument was that this represents the best level of evidence you could ever get. That if something has come from a systematic review, it must be believed much more so than something that comes from a source that's lower in that triangle. And of course, he went on to say, look, basically filtered information, and if you look to your right, you will notice that his argument was that filtered information, if it's been systematically and appropriately filtered. So if someone takes 60 studies and does the right things to evaluate them, and he uses those 60 studies to get an answer to a question, that represents a higher quality of evidence than someone who may use unfiltered information, which is at the bottom, than someone who might take one randomized controlled trial and decide that they will believe the outcomes of that trial over the outcomes of a systematic review or of an evidence synthesis or of an article synopsis. So basically what this hierarchy tells you is that in quantitative research, not all sources of data are the same. Some are seen as being much more credible than others. Those that are filtered, such as systematic reviews, critically appraised topics, those represent a higher type of evidence than randomized controlled trials, cohort studies, and at the very bottom is this expert opinion. So if an individual says, look, the truth lies this way because I say so and I'm an expert, their type of evidence, according to this hierarchy, represents the lowest level of evidence you could get if you compared it to a systematic review, to a randomized trial, and to a cohort study. This is an important thing because when we do literature reviews, you will get studies that are saying different things, and you need to have some type of method or system for deciding which one you believe in. So that speaks to that whole systematic nature of research that I spoke about. Secondly, another principle that is important is this principle of homogeneity. And basically, this argument is that when you do quantitative research, by the time you sample things and you make them part of what you're going to study, you need to have dealt with all the variables and cleaned them out so that the things that you're assessing can claim to be homogeneous, they can claim to be similar. So if, say, for example, I had a tablet, I had medication that I gave to people, and I wanted to make sure whether it works or not, and how quickly it works, and I was doing it as a quantitative study, there's an expectation that you would apply certain systems to eliminate all the people who are different so that you are left with people who are of a similar background, so that when you give them this medication, the outcome you get can be truly understood as being an outcome that's related to that type of individual. So you can't get 40 different people, 10-year-olds, 60-year-olds, 35-year-olds, males, females, disabled people, people who are able-bodied athletes and so forth, and all give them one tablet and give it to them and then say, this is the outcome. Because they are not of a similar background or are not homogeneous, that would not represent an appropriately fashioned quantitative study. So when you do a quantitative study, there is this unsaid principle that the group that you study must be sufficiently similar for you to draw comparisons between them. Then, of course, when something is homogeneous, and say in a group of human beings, you choose a very specific group, it means when your results come out, you can't generalize them to other groups. But what you do have is you have a lot of intra-group confidence. So you have a lot of confidence in the fact that your finding really is true for that one group that you studied. It may not apply to other groups, but it definitely is okay for that group. And so this concept of homogeneity is something that you in your research will need to assure and create in your study, so that when you're studying people, you really know that you are studying like for like, and anything that is different you've accounted for. Then the other concept that is important in research, and actually I will start with the sister concept, just so to make this easier. And this is the sister concept. This idea of variables. In a quantitative study, you have two types of variables. You have something that people call dependent variables, and you have something that people call independent variables. And it's important you understand that, because going forward, the entire conversation about quantitative research will be referring to this. And it's critical that you get that right. So I will describe the dependent variable, because once I make sure you get this, the other one becomes very easy to understand. So when you are when you're carrying out a study and you are interested in a particular outcome, that outcome in your study is the dependent variable. I know you're saying, what does it mean? What does it mean? Let me explain so you get it clearly. If, say, you were doing a study and you wanted to know what factors affect someone's intelligence, the fact that you are interested in intelligence, it makes intelligence your dependent variable. If you were interested in the factors that contribute to whether or not people succeed in a course, then success in that course is your dependent variable. If you're interested in whether what types of people run fast and what types run slow, your dependent variable is the speed of running. So the dependent variable is the result that you are interested in, and it is the thing that you don't manipulate. It is the thing that you watch to see what other manipulated things affect this. So it is so they refer to the dependent variable as the outcome variable. And in the studies you are carrying out as researchers at this level, when you're doing a master's and doctoral level study, you only have one dependent variable. So if you're interested in the uptake of a course, you are interested in failure rates, you're interested in treatment outcomes, you're interested in the speed of catalysis or whatever, it's that one thing that you're interested, that becomes your dependent variable. So your studies, when you carry them out for the purposes of your master's and your doctoral work, will always have one substantive dependent variable. However, they are the variables that you manipulate, and the variables you manipulate are called the independent variable. So it is those things that you play with to affect the outcome you're interested in. And now in your studies, you will have more than one independent variable. So if, say, for example, I'm interested in people's ability to succeed when they do their postgraduate studies, their success is the dependent variable, but the factors that affect their success, their intelligence, how hard they work, how motivated they are, whether they are rich or poor, those variables are called independent variables. So normally in a research study, you manipulate the independent variables to see what impact they have on the dependent variable. So in your study, when you write in quantitative terms, you will tell us that your independent variables are 1, 2, 3, 4, 5, 6, 7, and dependent variable is 1, whatever that is. But these are the two concepts that I need you to understand and have a firm grasp of, because we make reference to them throughout all the other work that I introduce you to. So, and I've provided quite good explanations of them on the slides, so when I'm not in the room, you're able to get them and get to the bottom of them. Okay, now cause and effect. The other principle you need to know is this principle of cause and effect relationships. So in quantitative research, we are ultimately related in the cause and effect relational presence between variables, the cause and effect between independent variables and dependent variables. So we are interested in the things that cause something to happen, and we're interested in that thing that actually happens. We're interested in the causal factors, we're interested in the effect or outcome variables. And there are some rules that need to be established and need to be clear before you can even study anything like that. Firstly, the first rule, and these rules seem simple, but they are necessary for you to even continue with the study. The first rule is that your causal variable, the independent variable, and your outcome or effect variable must be associated with each other. That sounds like a totally useless statement, but it is necessary. So take, for example, if someone were to say, look, I want to carry out a study to check if having a 65-inch television at home is related to the color of your wall in the house. There is no system of thinking, there is no knowledge on earth that suggests that those two things have any relationship. There's nothing we've ever read to say that having a white wall in your house and the size of your television have anything to do with each other. So if you conduct and propose a study like that, I can discount your study because it is reasonable to assume that your causal or independent variable and your effect or dependent variable have no foreseeable association with each other. So why on earth are you studying them? So when you study things, whatever you choose, you have to have given enough basis for the reader to believe the two things are related to each other. And how you do that is through literature reviews. You review literature that shows that X, when X used to happen, some have associated it with this particular dependent outcome and so forth. So you create an appropriate background for you to infer a cause and effect relationship between the things you are proposing should be studied. Don't assume the world know it. You have to develop it and ingrain it in the reader. Of course, the next rule is that the cause must precede the effect. What we are really saying is that in terms of chronology, if you are checking whether A causes B, we have to be sure in real life that B does in fact occur after A. If there is no evidence that the order is right, then we can't do a cause and effect study. So essentially, someone will say, we want to know if being stabbed causes someone to die. We can clearly tell that dying doesn't cause someone to stab. We know it to be the other way. So the cause must always precede the effect. And sometimes people will say they want a relationship between whether A causes B, when in actual fact, there is no suggestion that A comes before B. Then, of course, the relationship must not be explainable by any other variable. This last rule is the one that most of you who are in master's and doctoral work are guilty of. Many times people will be obsessed or very convinced that the things they are studying are associated with each other and one causes the other. And they forget that if they read much longer, they might actually come across research that suggests that this dependent that they are interested in, the dependent variable, could be caused by many other things. So someone will say, for example, that, hey, people, they want to assess whether being in a house with someone who drinks will cause the child to also be a drinker. You cannot study that as a cause and effect relationship, because guess what? Someone else could offer equal evidence to suggest that being a drinker is caused by many other different things. So we can't for a fact say that that causal relationship is the exclusive cause of one variable. But if you know all the implicated variables that cause being a drinker, you can then say, look, instead of asking if one independent variable causes drinking, I must understand all the important, significant independent variables and ask whether they all collectively contribute to the causation of drinking behavior, and then also understand numerically the strength of relationship between each other and so forth. So what this last one does, this last rule basically says, look, when you create studies, be absolutely clear that the variables that you believe are the complete independent variables are actually the only foreseeable ones. Because if you miss it, and an examiner sees that you've assumed that A causes B, when there are other things that are known to cause B, they can actually discount your entire study. So, with that as the background, those are all really important concepts that you need to have. I can now get into quantitative research methods, and in that, I'm going to walk you very quickly through this because they are very simple once you've got it, and it's all kind of common sense once you get the original thinking. So in broad terms, people talk about quantitative research as being about, they call it relational research. And relational research is you are literally studying the relationships between known variables, known independent variables, known dependent and measurable variables. So that's quantitative research is known to be about, it's generally called relational research. And in that, as you become more complicated in your understanding, you can give a description about what type of relationship you're interested in understanding. So some people will talk about a correlational study where they are looking at the relationship between two things, correlational, like how does A correlate to B? That is what correlational research is. Then, of course, you have causal research, which also falls under quantitative research. And in causal research, your interest is, does A cause B, does B cause C, and so forth. Then, of course, there's comparative research, and comparative research is literally looking at two different items or two different variables and comparing their impact on a particular effect or outcome dependent variable. So essentially, quantitative research splits itself into correlational research, causal research, comparative research. Sometimes it's a mixture of all. It doesn't matter too much how these things are mixed, but when you see those words, you now have a very clear sense of what it is, the nature of the relationship that is being explored. But ultimately, quantitative research is primarily about relational understanding, numeric relationships between things. Of course, with every research design, whether that research design is quantitative or qualitative, it gives you a plan or a blueprint for testing out your questions or your hypothesis. So once you know which design you have, that design comes with rules. It gives you a set of rules that you should follow to get to your destination of understanding a question better. It also gives you some structure. It gives you some structure, and it offers you a strategy, so you can have some control and stay close to how you are meant to behave if you're going to assess or measure something. So research designs are basically just a blueprint. They're a blueprint that allows things. So once you name something appropriately, then all the expected ways of behaving become defined by that name that you appointed to it. So if you say, hey, I'm doing a comparative study, then immediately the rules that go with comparative studies kick in, and so forth and so forth and so forth. And that is true of a research design, be it qualitative research, quantitative research, the same is true. So when you are talking about quantitative research, firstly, we need to be sure that the way you create you conceptualize the problem you're interested is deeply embedded in numbers. So when you're saying you want to study something, you're going to present to us the problem in terms of its numeric appearance, in terms of its the numeric comparisons that exist, the numeric relationships that have been posed. It is really around that. Then, of course, once we have decided that, we need to understand, what type of relational insight are you looking at? Are you looking at comparing how two things relate to each other? Are you looking at whether A causes B? Are you looking at how A is related to B? Are you going to, so that whole correlational, causal, and comparative aspect is central to this. It is important also in quantitative research that because we're interested in ascertaining or stating, making claims about the numeric importance of certain things, accuracy is everything. Secondly, and this is true of all studies, the very nature of quantitative research is that they involve large numbers. So the issue of feasibility, there are some things that you opt out of by virtue of them being too intensive for you to be able to carry out as a single researcher. And when you don't choose them, the reason you've opted out of them is more to do with them being a feasibility challenge rather than them being unnecessary. Then, of course, I've spoken about this issue of control and intervention fidelity. All I'm just saying is that because quantitative research is about ensuring that you are consistent in what you do, you must stay close to the rules of how particular things are carried out. So when we talk about intervention fidelity, fidelity means how well you comply with a specific framework of doing things. So if, say, for example, you're going to measure if a tablet A can result in people improving, the expectation is that in quantitative research, you would administer that tablet in exactly the same way with everybody, and you would stay true to you would comply to how that intervention should be facilitated. So when you're measuring it, you are really measuring like for like. Then the other thing that we are very stuck with is this concept of validity, internal and external. So what we mean by internal and external validity is when the concept of validity is to do with whether the thing that you claim to be measuring is indeed the thing that you are measuring. I know that seems strange. It seems like I'm running you around in circles, but it is actually a very viable concept. It is a very viable concept to have and to consider. So imagine this. Every phenomena that we explore must be defined appropriately for us to truly be sure that we are exploring the thing that we claim to be exploring. So say, for example, if I was claiming that I want to measure people's intelligence, for example, I keep using similar examples, but that's because it allows us to continue the story and the thing we're interested in consistently. When people talk about internal validity, what they are saying is that, are my measures that I'm using truly indicative of this concept of intelligence? Is my sense of what and the way that I've painted intelligence consistent with how that concept is understood? So, or if I'm measuring, whatever it is I'm measuring, am I truly really measuring that thing? And then, of course, external validity relates more to whether the relations that I have assumed in relation to that thing are indeed realistic to assume. Are the comparisons that I draw between what I'm studying and the rest of the other concepts, do they appear to be truthful? Do they appear to be as close to the reality as we understand it? So that's what internal validity and external validity refer to, but they are really to do with measures of how true or how accurate my depiction of the things that I'm measuring is. Am I really, when I say I'm measuring X, are the things that I'm doing consistent with how X would be measured? And if I say I'm measuring X in relation to the rest of the world, in my external comparison of X, does it appear to be truthful as far as the world and our current knowledge suggests it ought to be? So these are some of the considerations that are central to quantitative research. Now, in quantitative research, I've told you that in terms of relationships, there is the correlational relationship, there is the causal relationship, there's a comparative relationship. Now, in the way that people would study, and when we talk about designs, we are now talking about we are talking about the different ways in which people move and act in relation to different types of quantitative research. And essentially in quantitative research, there are three broad groups of designs, three broad groups. One design is experimental designs, where you actually do something. You take A and you inject B into it and you see what happens. That is an experiment where you actually have a very active intervention that the researcher specifically introduces for the purposes of studying a relationship. So they are carrying out an experiment. The traditional thing where people go to a laboratory and you inject or you burn something. That burning, that injection is your intervention. That is an experimental design. Then there's another design that they call a quasi-experimental design, and the quasi-experimental design relates to a type of research where you do some things that happen in experiments, but not all the things. And that's why the word quasi. So quasi means looks like. It emulates an experiment, but it is not an experiment. Then finally, there's a design called a non-experimental design. And in that design, people just watch things. They basically watch how A happens. They watch how A happens in relation to B and they report on it. So they do nothing. So there is one design or one group of quantitative research where people actually do active experimentation, where they follow the rules of an experiment. Then the other middle group is where they do what's called quasi-experimental activity, where they kind of do what an experiment is, but not everything. Then there's the last one that's called non-experimental. Very simple. 1, very clear intervention. 2, sort of. And then 3, no intervention. They just watch how things are. So if, say, for example, I am interested in knowing whether people sitting in the sun results in them getting darker. I could literally take people and force them into the sun and watch them. That would be an experimental design. A quasi-experimental design will be a slightly more difficult one to explain using my example, but a non-experimental design is if you went to watch people who are already sitting in the sun and watched whether their complexion changed or not. You have not injected an intervention on them. You've watched them go through an intervention that was not your doing. That is non-experimental. It's observational. So the different types of designs within quantitative research are experimental, quasi-experimental, and non-experimental. And what I'm going to do is explain the difference to you with each. And of course, once you understand, like with experimental designs, we are literally using these to test cause and effect relationships. So I throw you in the sun and I watch what happens, and I can say, the sun caused this effect. With non-experimental stuff, I see you sitting in the sun and I see you getting darker, but I can't entirely say that your darkness was caused by the sun, because I don't know what else you did before you got to sit under the sun. So different types of designs allow you to enter into different types of explorations. Now, okay, three properties. There are 3 things that you look at when you're deciding whether something is an experiment, a quasi-experiment, or non-experiment. The first property you look for is this property of randomization. So in all quantitative research, in a true experiment possesses 3 things. There's randomization. So the things that are being subjected to a particular independent variable, the independent variables that are being subjected to a particular experiment, they are randomly selected. Secondly, a true experiment has a control. It has a similar homogeneous group that have been excluded from the experimental intervention. So, and then finally, the last property is that there's manipulation. Manipulation being the insertion of that variable the insertion of that intervention. So a true experiment, the items in a true experiment are randomly selected. There is a group that is a control group who don't receive the intervention, and there's also the study group who receive the intervention, and then there is actually an intervention that is given to the study group. So that is a true experiment. And an example of that is a randomized clinical trial, and people will say that this is the gold standard of quantitative research, where you know absolutely that A happened because I inserted B and I randomly selected people. I used all the perfect rules for selecting, and I also have a group that were not exposed to this intervention, and they showed no change. So I can clearly say that the change was exclusively because I manipulated a particular element. That is a true experimental design. Of course, many of the human problems that we study do not allow you to do these things. You cannot, it becomes difficult to say, look, I want to know if a particular treatment will work for this and not for another. Let me deprive one group of this treatment and give another. Usually that process is considered to be cruel, and for that reason, many human experiments can't follow the true experimental design. But when people study nanotechnologies, chemicals, and other things, this is a very valid design option. So after the true experiment, there is what we call a quasi-experiment. And a quasi-experiment is actually, sorry folks, this thing about randomization, it's all an example of something I've already described with you. I spoke about control. I spoke about even manipulation, which comes up now. But what the next thing that I want you to focus on is the next type of of experimental design, this middle of the road experimental design. It's not quite an experiment, but it possesses some of the characteristics of an experiment, and we call this a quasi-experimental design. So a quasi-experimental design usually means that a couple of things are happening. So this, when we say experiment, we are actually saying that an intervention happens. When you experiment with something, you do insert, you manipulate something, you create an intervention. But a quasi-experiment is one where the activity will obviously have manipulation, but may be missing one of the other two remaining things. It might be missing control, it might be missing randomization. So out of the three things, we said an experiment had randomization, control, and manipulation. A quasi-experiment will have manipulation and only one of the two others. So it will have manipulation and control, but no randomization, or it might have manipulation, randomization, but no control. And this happens usually when you are studying groups where you have limited ability to create experimental conditions, where you can't create laboratory conditions. So for example, say if you were studying whether a particular current treatment works or not, and you don't have the ethical power to say, look, I'm going to deprive this group of this treatment while I give other the treatment, because it could be seen as being inhumane or cruel to exclude people from a particular treatment while you're studying it. So that means you don't have the ability to create a control group, but you are able to test what happens when you give people this medication. You are able to randomly select them. So you are able to achieve 2 out of the 3 experimental conditions. That is a quasi-experiment. A quasi-experiment will always have manipulation, but it could be missing one of the other 2. Then, folks, a non-experimental design, which is not described here. Non-experimental design is when you remove. Remember, an experiment is essentially to do with manipulating something, adding something. The minute you remove that manipulation and you are left with control, randomization. Well, actually, if you remove the power to manipulate, and you are now no longer actually injecting an intervention, you are just watching things. So a non-experimental design, it is a quantitative design that does not have experimentation, does not have manipulation, does not have control. It will just have randomization. But those are the different thresholds of experimental designs that you get. Where you really do the true experiment, you create laboratory conditions. The other way, it's a quasi-experiment where you can't create the perfect experimental conditions, but you're able to at least have 2 out of the 3 required experimental conditions. And non-experimental is when all you are really doing is observing how things relate to each other and making deductive conclusions about how things are related to each other. So in this world, there are subgroups. There are subgroups. When people talk about quasi-experimental designs, you will occasionally meet different words that people will use. So they will say, oh, there's a quasi-experimental group where we shall call it a non-equivalent control quasi-experimental design. They're basically saying, when we're saying non-equivalent control, we are saying that there is no equalness in the controls. So someone is telling you that this is a quasi-experiment, but the reason it's quasi is because it actually doesn't have a control group. No, it has a control group, but it is non-equivalent because it has no randomization. So we are saying it's not equal by virtue of it having a control group and lacking something else. So that non-equivalent control group design means that you're saying it's a quasi-experiment, but the reason it's quasi is because it has no randomization and it has the presence of a control group, but the absence of of randomization. And then you may meet what people will call a non-equivalent randomization group design, which means the opposite. That you are saying, look, it is experimental because it's a quasi-experiment, but it is lacking. In the latter example, it would be lacking a control group, but would have randomization, and each of them affect you and your research space differently. But the detail of that we will get into once you decide, once you get into the actual research itself. Now, remember, I've spoken to you about non-experimental designs, and remember the non-experimental designs are where you are not manipulating the independent variables. So you are not taking the dose of a medication or the exposure to the sun and playing with it. You are just simply observing how it acts, and you are not experimenting. It is essentially observational research. So in that world, there is types of it's called observational research. Some people will call it non-experimental research, but essentially the hallmarks of it is that you don't manipulate things, you just watch them. You don't randomize subjects because you study what is there. You don't have a control group because you didn't have a manipulation group, so you can't have. And all you can do is to just understand the relationships between people, understand the differences between things. You're able to compare things without actually touching them. Now, I thought it important that I just speak through a couple of the experimental research examples that are out there. And the correlational research example is the one that you're likely to meet. Then there is causal and comparative research, which I've given some insights into, but the following slides give you a bit more detail so you work with it. As I said before, correlational research is to do with the interrelationship or association between two variables. So when you say correlate, you are saying you want to understand the relationship, the interrelationship between these two. The tendency for one variation in a variable to be related to a variation in another. So for example, in human adults, physical strength and gender are correlated because we know that, and this is not a sexist comment or whatever, it is scientific discovery that tells us that there is a tendency for males to have greater physical strength than their female counterparts. So we know that the gender that you're allocated to has some association with the type of physical strength you have. We have two variables there, and that is it. And the correlational element is to do with just understanding that. Relational research on the whole, as I had said, was looking at just basic relationships. And in that, some people will talk about correlation research, where you just look at whether A is related to B, or predictive research, where you understand and observe how a particular thing can predict the occurrence of the next thing. So something like if someone watches violent television as a child, you can make some predictive understanding of how that might result in them being more violent when they grow up. Even in that subgroup, there's and there are slides that I have here that talk about that. I won't focus on it, but I want you to just have access to it. That when you do predictive or correlation research, if you're doing research that looks at relationships, you can look at relationships as they are playing out now, and you assess how the past had an influence on these relationships, or you can take two variables of interest and follow them into the future to understand how the two of them impact each other or are connected to a third other variable that you're interested in. So, and research that takes variables now and takes the dependent outcome today, the thing that you're interested today, and looks at how past variables may have resulted in its occurrence. That research that looks to the past is called retrospective relational research, and research that looks at the here and now and focuses it on how it could impact the future is called prospective research. So I would take an example. Say if you are someone who wants to study violence in people, and you go and you meet people who have already proven themselves to be violent, and maybe they're in jail because they did something violent, you can look at known related variables from the past and see how explore how you think they contributed to their current status of being violent. Your decision to research their past to understand the current, that is retrospective research. So the independent variables that you are looking at their actions and their occurrence retrospectively. That is retrospective correlation research. If, say, for example, you had a good sense that certain independent variables, if they exist in people, they can lead to future violence. And say, for example, you met people who are children right now and are not violent, and you tracked these particular independent variables and you watch them for years to come to understand how they are going to turn out. That is prospective research because it's looking at the future. So you as researchers, in the way that you are likely to do research, because you are doing this for study, you are all likely to end up doing prospective research. And I'll explain why. The logic is, often for you to have very sound confidence in a prospective or predictive measure, you need to watch something for a very substantive length of time. So if you wanted to know whether watching violent TV will result in people being adults, for your master's and doctoral study, you couldn't go and study children now and then say, I'll watch them for 18 years so I can write about it when they're 20. because essentially that means your master's and your PhD will take 20 years. But if, say, so clearly the prospective method is not appropriate for the nature of research you're doing, and that's where, when we were saying this feasibility consideration is a serious one when you're doing quantitative research, you also make decisions about whether you can study something in a particular way because of the feasibility of it or the lack of feasibility. But if you wanted to study the same variables and you thought, I am going to go to people who have a known history of violence and track as best as I can the contribution of certain predictor variables to how they've become now. You can do that through comparative research. You can do that through observational research. You don't do anything yourself. You just track and map out particular variables that existed throughout their life. So you realize already that your choices in terms of relational research are guided by what is possible, what you have access to. So the next few slides, this slide, this is also the slide on correlational research. I spoke to you about some of the retrospective designs. I give you examples of them. I will speak to you also about some of the prospective designs. I have given you examples of this. What I probably did not mention is give some of the naming conventions. So when you do a longitudinal study of a group of people who are going through the same phenomena, you call that group a cohort. So you can say, actually, you've got a cohort design correlational study. And what, folks, what is going on here as I describe all these concepts is that I'm actually giving you the power to be able to name your study accurately. So those of you who do quantitative research, you can now say whether your study is experimental, non-experimental, or quasi-experimental. You can say whether it's relational, correlational, causal comparative. You can also say whether it's prospective or retrospective. So essentially, if someone say, tell me what your study is in quantitative research, you'd be able to say, look, I'm carrying out an experimental or a non-experimental prospective cohort design study. And once you've said that, anyone who listens to you can immediately tell that you are not going to manipulate anything. You are going to be looking at prospective occurrences rather than retrospective occurrences. So it gives a lot of insight when you know how to name. But it also helps you, once you know this, it helps you to know what choices of modalities for collecting data are available to you. Because once you decide that something is non-experimental, I now know that I don't expect you to be measuring anything when you're doing it. If you're saying that it's retrospective, I know that one of your methodologies would have to look at old records and so forth and so forth and so forth. So a lot of everything that I've described so far emerges in one shape or form in relation to these things. Of course, people will say, look, you've told us about experimentation and you've told us about observation or non-observation. And we want to know the strengths and limitations of another. When you do experimental research, the causal attribution is much more obvious. If, say, you have someone standing here and you want to know whether burning them with a fire causes X, you can say quite confidently that when I applied the flame, they cried and jumped. So I know that the flame caused this. But if you met someone who's already burnt and you are not the one who manipulated the burning, and you ask them about how they got there, their explanation about how they got there could be affected by a lot of other confounding variables, lot of other variables that they don't describe to you. So your confidence in the causal relationship is weaker in observational research than it is in true experimental research for reasons that I have explained to you. And of course, when people talk about the strengths of observational research, they talk about it having strength in realism. We know that if you study things in their natural environment and you study how they operate, you are literally studying the outcomes in a real life situation. But if you put people inside a laboratory and you subject them to a particular intervention and you get an outcome X, you cannot with definite confidence say that the conditions under which you did what you did represent reality, because they don't. Nobody lives in an experimental laboratory environment. So there are strengths, comparative strengths between all these choices. What I've done with the next 10 or 15 slides, and I'm going to pace through them, is to give another interesting insight into some of the causal research that's out there. And I will share these with you. You have them to look at as and when you wish, but we don't really need to engage in them because you already have had exposure to them. You have had exposure to them. I also offer some similarities between the designs where you look at things and the designs where you do things. I also give you some insights into the differences between each of them. So we will engage with that. What I want to do now is to take us to the next world. Sorry, please excuse me. I am just going to take us to the element that we need to work on, and this is this element here. Okay, part 2. Now, I just want to very quickly go through certain concepts that relate to data collection, and this would have been the second session, and this is where the summarization will occur, because a lot of what I'm showing you now is quite, it's very straightforward stuff that you can do, but you need to have been exposed to. So folks, remember, in quantitative research, you collect data for the specific reason of being able to have enough insight so that you can make reasonable predictions about what is going on. So, and that's the first ground rule. The second rule is that when you sample in quantitative research, you are selecting a subset of the group of interest, the minimum number that's needed for you to get the confidence you require. So it is about the minimum number. And if you had 100 people and you wanted to study them in relation to something, and you were carrying out sampling from a quantitative point of view, the secret is to look for the smallest number that allows you to have mathematical confidence to be able to say, I fully understand what this whole group involves. So many people would think, well, if there's 100 of them and I want to do a sample, why don't I just ask all 100? The reason you don't ask all 100 is one of the rules of research is this thing they call parsimony. And parsimony is just about being frugal, being conservative with the resources you have. So if you have a class of 100 people and you want to know whether they think this is a good lecture or not, in quantitative research, the rule is that you don't ask all 100. You look for a mathematically acceptable calculation that will tell you what the smallest number you need to speak to get the confidence is. So, and that is where the whole basis of a sampling plan is. So many people say, oh, I'll just ask all of them because it makes sure I now have 100% insight. In research, that is seen as being wasteful. It is not accepted, it's frowned upon, it's something that we don't do. So essentially, sampling plan is about looking for the small, mathematically acceptable number required for you to get a representation of the sum of the bigger group that you're looking at. And that's the basis of where we start with all of this. So sampling is a process of selecting a portion of the population to represent the entire population so that inferences about the bigger population can be made. And in that, there are some key terms that we need to know. And these key terms are important, particularly for you when you write your proposal and you are preparing your proposal under the section that's called sampling strategy or your sample development plan. You must familiarize yourself with these terms because we expect to see them. We expect you to utilize them. So we use the term population to talk about the entire sum total or aggregate of cases in which your researcher is interested in. So if, say, for example, I was going to study student success, I was going to study results from students at a university, then my population are the whole university student population. That's what I call my population. And of course, if that population is taken from a list, registration list of all the students at a university, then we call that list, the source material or device from where the sample is drawn, we call that list a sampling frame. So when someone says, what is your sampling frame for students at a university? It is the list of all the registered students that are there. What is the population? The population are the students who are registered, but their list, the list from which you drew them from, is called the sampling frame. Then in that, there is what is called the target population. So these are not listed in any order really, but the target population become the small group within your bigger population that you want to study and make generalizations about. So if, say, you wanted to know what the success rates of students in a math class are at a university, your population would be all the university students. Your sampling frame would be the list of all the university students. Your target population would be the students studying maths and the ones who took the exam. Then your accessible or source population are those members of the maths students or the ones who took the exam who are available for you to assess and to investigate. So if some, for whatever reason, are not available, then they become inaccessible to you, so they are not the source population. It is possible that someone's sampling frame, someone's population, their accessible and target population are one thing. They could all be one number. It is possible, but it's very rare. The sampling frame are the total list from which you draw your people. The population of interest are, so if the sampling frame may be all the students that are registered at that university, that list of them is where you drew them from. But your population would be the list of students who are in classes that take exams. Your target population are the list of people who took that mathematics exam. Your accessible population are the list of the people who from taking the exam are available in one way or another for you to truly study as your subject. So when you give us your sampling plan, it should have this detail, all of it. But you can only have that detail if you know what those terms and words mean. Then the other concept that's important is this concept of inclusion and exclusion criteria. And this is basically you saying, look, there are some participants who appear to be, or some subjects or some units of investigation that appear to be appropriate, but for one reason or another, I'm going to include them or I'm going to exclude them. So inclusion criteria are those rules that you have to determine what can be included. So if you say you are including people because they speak English, you are including people because they studied in the last year, you are including people because they are well enough to respond to your questions. All those are inclusion criteria. Sometimes you have criteria that you use to decide that something cannot be included, and those you call exclusion criteria. So when you develop your sampling, your sample size, you tell us who is it that you excluded, who is it that you included, and so forth, using these typical criteria that I'm sharing with you now. In quantitative sampling, as is the case with qualitative sampling, there is a set of logical steps that one pursues. You first tell us what your target population is. I've explained to you what target population is from the last 2 or 3 slides. You then tell us from that look, I'm targeting people who studied mathematics. Then you tell us out of that group who is accessible and who is not. Then you explain to us the list from which you drew these things. Some populations that you study will not have a sampling frame. They might not have a list that you can tell. Like if I want to study BMW drivers over the last 20 years, there is no known place that can tell us every single person who's driven a BMW. So we don't have a sampling frame, but we can identify a target population, we can have an accessible population, and so forth. Then, of course, there is this whole set of how you apply particular methods of sampling to determine who you include. And this is where this thing comes in, that in quantitative research, we deal with something that people call probability sampling. Probability sampling is simple, that you are choosing subjects from your study for your study on the basis of mathematical chance. That if you are selecting items that will be included for your study on the basis of certain rules that guarantee a mathematical chance that they will be included. And there are 4 specific types of sampling that you need to be aware of at your level of study, because if you're doing a quantitative study, you must subscribe to one of the 4. Firstly, the most simplest of them is called simple random sampling, which is essentially saying, look, my target population is 4,000 people. I'm going to randomly identify X number of them. I don't know, you can do that mathematically. I mean, the easiest form of random sampling is to take your subjects, put them in a hat and just choose without seeing them prior to that. But these days we have mathematical things that will assist you to do that. But simple random sampling is that. Stratified random sampling is a type of random sampling, but it's a very specific type of random sampling, and I will speak you through that so you get to see and understand how things differ. Then there's something called cluster sampling, which I will also talk you about through, and then there's something called systematic sampling. And once I share these different types of sampling options, you now know that when you're selecting the subjects that you look at, these are the formats that you've got available to you. Random sampling, as I said, is a basic building block of all probability sampling, that every one of the other examples of sampling that we'll talk about uses a form of randomization in it, the selection of people randomly. But we are saying that everything that is selected as a function of chance, that, you know, you're randomly selecting things without any preference. All we say is that these 70 people meet our eligibility criteria, and each one of them has a 1 in 70 chance of being the person that we will interview or we will subject to the intervention, depending on what it is that we're doing. That is simple random sampling, nothing there. Stratified random sampling is a form of random sampling, but actually what this involves is that if you as a researcher are aware of specific homogeneous, remember I spoke about homogeneity. If you know if you're aware of a particular homogeneous effect that needs to be taken account of, you can then separate, you can then prioritize particular types of groups. Say, for example, if I wanted to study, randomly select these mathematical students that I was talking about, and I had 90 of them, I could just take all 90 and mathematically just randomly select whoever. Or if I realize that, look, I was at a university that had girls and boys, or I was at a school that had girls and boys, and I realized that girls performed or had different types of intellectual ability from boys, and I wanted the girls to be represented in my study group in the same proportion that they exist in the school. If, say, the school had it had 500 kids, 450 were boys, 50 were girls, and I wanted even my sample to have that same proportionality. Then I could maneuver it and say, look, I want a stratified sample where a big percentage, a proportionally appropriate percentage of my subjects would be boys versus girls. So I've separated them out according to the subset that I believe is homogeneous. One homogeneous group is the boys, one homogeneous group is the girls. So I end up with a sample where I have engineered it so that the boys are at a ratio that's similar to how they are in the big school. Those strata that I've created are what make this stratified random sampling. So it's not just selecting any random 90 kids. I've said, no, out of the 90 kids, I want to make sure that there's a 1 in 10 representation. For every 10 boys, there's 1 girl. That's the rule that I've set in, is created a homogeneous subset, and that is called stratification. So I've made a proportional strata. And then sometimes people will talk about a proportionate or a disproportionate strata. So for example, if I knew in the school there was, for every 10 boys, there was 1 girl, I can stratify my sample so that when I get my sample that I study, it is 10 boys to 1 girl. That is called a proportionate strata because it's proportional to the parent population, is proportional to my source population, and I've engineered it that way. But if I knew there was a 1 in 10, that for every 10 boys there was 1 girl, but my interest was that I just want us to have some girls and some boys. And I wanted to make sure that half my group were boys and half were girls when I studied them. And that proportion had nothing to do with the source population. It was only to do with me just wanting to have some boys and some girls. And I said, let them be half-half. That is disproportionate to the group from which I got them, and we call that a disproportionate strata. So you can decide, it's totally up to you. You can say, look, you are doing a proportionate strata or disproportionate strata, and a stratified sampling. Sometimes people will do a disproportionate strata on purpose. They'll say, look, the school I studied had 10 boys for every 1 girl, but the big life that I want to generalize my research to is actually got 1 boy for every 1 girl. So I am going to stratify this, but I'm stratifying it in accordance with the world and not with the school. So then that's how they make that decision. So that's stratified random sampling. The next option that I've spoken about is this thing that they call cluster sampling. So this is cluster sampling is sometimes people call this multi-stage sampling. So say, for example, you were studying success rates in students, but you were studying them in students that were in class A, class B, class C, and class E. You know how you have different grades in one, different classes in one grade, the clever ones and not so clever, the A, B, C, D, E. If you decided that, look, for each of these individual classes, I'm going to randomly select from class A, randomly select from class B, randomly select from class C, randomly select from class D, and I'll take those random representatives and make them my study. Then you have cluster sampled. Or sometimes people will say, look, I want to study all the hospitals in this country. I want to understand all the hospitals in this country, but I can only study 4 provinces. So then you must sample, randomly select 4 provinces out of the 9 that South Africa has. Then you can say, in these 4 provinces, I want to do 3 towns. 3 towns each. So in those provinces, you now randomly identify 3 towns. Then in those 3 towns, you say, I want to identify 3 districts. Then you do 3 districts. And in the districts, you say, I want to randomly select 3 roads. All that sampling upon sampling, multi-stage sampling, that represents what we call cluster sampling. Of course, people will argue that this is less representative than stratified methods because you are sampling from structures without understanding who is in those structures. So you sampled from 3 provinces out of 9. You don't know really how the provinces compare to each other and so forth. So it is not representative, but it's easier. It's economical, it's much more practical. So people can choose cluster sampling for that reason. Then the last form of randomized sampling that's there is this form that they call systematic random sampling. So this actually is interesting because it is some question whether it is really true probability sampling or not, but it is a form of quantitative sampling nonetheless. And in this form of sampling, what happens is this. If you are studying a population where you don't know the frame, you don't know the limits, you don't have a list of how many people constitute the big population from which you're drawing from, then people will do this systematic sampling. So say, for example, you wanted to gauge the opinions or assessments of people who shop from a grocery store. You don't know how many people are coming that day, but you want to go to this grocery store and ask them to complete your survey. And you decided that, look, I don't know if 70 people are coming to the grocery store in a 24-hour period, or whether 2,000 or whether 5,000. But what I do know is that I can systematically choose the 4th person who leaves the grocery store and make them my subject. So every 4th person that you look at becomes your identified subject. That is called systematic sampling. It is, and that's where they say you draw out your subjects through predetermined intervals. And those intervals, all these things, by the way, folks, are things that you can now mathematically do, so or automatically do, and you don't need, like some of us had to, you don't need to do this yourself. And this is where the function of of this latter, very last thing that comes is involved. And I want I'm going to just very quickly show you something. Folks, I'm jumping all these because they're explaining things that I've touched on already. And what I want to do is this thing. Okay. Okay. Whoa. Right. I just want to show you. Okay. Now this is the last slide I want to show you, and this kind of undoes everything I've shown you. So even though you have been given all that basic information that I've been given to you, all of you have access to computer-based sample size calculation options. So what I gave you gives you an insight into things, but there are two particular engines that I use. One is EpiInfo, and the other is StatCalc. And basically what EpiInfo and StatCalc and others, there are many of these actually online, and they're all reasonably similar. What they do is they help you to calculate your sample size. But for you to be able to calculate your sample size, you need to input various types of information into their engine, and then it will make decisions. So it will ask you, what is your sampling frame if it's known? So what size is your sampling frame? 10 people, 2,000, 4 million, whatever. What is your source population? You input a number. What is the size of your target population? Out of this big group, how many are in the group that you are really interested in and will be generalizing about? They also want to know what confidence do you want to have in your sample size. And there is a ratio called a confidence interval, which is essentially just a measure that you want. It's a measure that we speak about in sampling to say to others how confident you want to be that your assessment of a particular cause and effect relationship is not the subject of coincidence. In simple English, what I'm saying is, if you want to be 95% sure that your sample will have enough items in it for you to really be confident that the answers you get are the objective truth, you can put in 95%, then it will calculate a sample based on your required level of confidence. For the research that we are at, we accept anything above 80% and up as confidence level. Anything lower than 80%, we don't accept that. So when you are inputting into your sample size calculator, you aspire for 95%, 99%. Those numbers are what you really want if you want to have a sample size that gives you confidence that you truly measured the phenomena you are trying to measure. But usually when you put that type of confidence value, you will see that the sample size it asks for is ridiculously high, and often you don't have the feasibility capability to do it. But then you can then say, okay, I can do with 90% confidence, and you input that and see what value it gives you. So all these engines do that for you. But what these engines do, which you need to be very good at, is you will input those things and they will tell you that this is the sample size that you require. But then they will also say to you, this is the background formula that we used to get the sample size. And when you write in your proposal that your sample is going to be 400 and you use the EpiInfo sample size calculator, you must then say, and the formula that was used is this, and actually share with us the formula that was utilized, and then also tell us what the confidence level that you wanted to aspire for is, and so forth, and the error the margin of error and so forth. All those details become things. We have an entire session where I walk you through the use of sample size calculators and so forth. But this is basically the information that you need to know in terms of getting ready for the world of sampling, the world of quantitative research, the understanding the differentiation between experimentation, quasi-experimentation, non-experimental techniques, observational research, relational research, correlation research, and so forth. So that is the session and the overview of the material. And for that, I then now ask that you allow me to look at the questions that you have presented. Now, I am just about to revert back to showing my face. I am going to turn this on. I'm just turning on the question and answers. Folks, what I've presented is very, very long because we've combined two sessions. I also am hoping that you will revisit it. This is material that is very difficult to look at. It's very difficult to look at once and actually feel like you've got you've got it ready and fully understood. So you need to repeat this over and over. What I am going to now do is to look at the questions that we have. Right, I am looking through this. Okay, I've noticed there's a specific reference and acknowledgement of the qualitative versus quantitative research slide. Folks, that is, it is a very good slide to focus on. It's one of those things that you can do to just check that your work is aligning very clearly to what it promises to align with. That if you claim that your study is qualitative, you should check whether those elements that I said are typical of qualitative studies are indeed in your study. And if you claim that is quantitative, you check the same, but along the different criteria for quantitative research. Thank you, Richard, for your comment about looking at the same for qualitative research. Interestingly, qualitative research is got less rules, so it tends to be much more conceptual. You know, a lot of the things you get are given to you at a conceptual level, and the application, the detail of the application is not often given, but it is indeed, the rules are indeed similar. So it says, thank you for the informative session. I would like to know the percentage of the population that is representative. So Itumeleng, I cannot predict what representativeness looks like for different populations. But what you can now do is, as I said, if you use, say, EpiTools, EpiInfo, you are able to say, okay, I am going to study, I am drawing my population from a group of 1,000 people. And from those 1,000 people, these are the other numbers. This is the source population. This percentage is accessible, and so forth. Once you input those, it then gives you a sense of what is representative. There isn't a static percentage. The basic rule is this: the smaller the population, the higher the percentage. So if there were 10 people and I said, what is a representative percentage out of 10? Probably if you do the calculation, you would find that you need 7 people out of that 10, so 70%. But if I gave you 1,000 people, you don't need 700 for you to be representative. So you don't need 70%. You probably will now need 284 or so. But all of those things are the subject of your statistical calculations for representativeness that will come from those tools that I shared with you. So I hope that says something, and thank you very much. One of our facilitators has actually given you a direct link to EpiTools. Folks, please use this. It is a very useful tool. What I ask you to do is that when you do use it, remember to copy and paste the formula that comes up. There's a formula that will come up saying, this is the formula that was used in your particular example. Your examiners and everybody wants to see that. It's not enough for you to just say, oh, I got this from EpiTools, and to not mention the actual sample size formula that was used. Then the final thing that people do is there's something called attrition, which was on my other slides that I didn't touch on, is that if you are dealing with human subjects, people will anticipate that there's a likely dropout rate, and the dropout provisions people make are anything from 10% to 25%. So if, say, you wanted to interview 10 people and you thought there was a 25% likelihood that they would drop out, then you would invite 12.5 people so that when that 25% drop out, you're still on your 10, that type of thing. So you can build all that in, and it was in my latter slides. I didn't really speak to it, but it's quite straightforward how you do it, and I'm expecting that when people review their work, they'll get to it. The session will be recorded, folks, and as I say, those of you, and it should be every one of you, who've got the program of all the sessions in that one document that we share. If you click on today's session, well, once we've prepared this recording, you should be able to get the recording. And with that said, I think we are well placed to call the evening an evening and say the session is done. I know that tomorrow we have another session which will be presented by my team, and I think I will be in the background somewhere. So I invite you to join us tomorrow for the session that we have. I need to orientate myself with what the session is, and I am going to look just now, but I'm hoping that one of my facilitating team will share the title of the session with you before me. These things tend to blow into each other for me. Let me see what we have. I know that this week we have, okay, there is the counter of this session with the qualitative research. So I'm inviting you all to join that. And of course, we will continue to work through the research process for you. And now, thank you. Right, I see. Perfect. Okay, colleagues or dear students, M&D students, I hope that this provides you with the necessary information to delve into this issue of quantitative research methodologies. And we look forward to seeing you tomorrow, same time, same place. I want to thank you for everything. And on that note, I will say goodbye. Thank you.